Today we'll be looking at stoichiometry, and this is a very powerful technique that allows us to go from the grams of one substance to the moles and subsequently to the amount of atoms. And additionally we can go vice versa, from atoms to moles and to grams. Lastly, it doesn't have to be from one substance to that same substance. It can also go from one substance to another. So for example, it could go from H2O to H2O, or it can also go from H2O to CO2. And it's very powerful in the sense that it allows us to figure out the amount of atoms in H2O or any other substance. And the same thing with grams or moles. Let's start off by reviewing the mole. And the mole is a quantity that symbolizes one molecule, particle, or atom. In that sense, it's very similar to a dozen. When we say a dozen, we know that it represents the number 12. So we could say a dozen eggs, and we would know that we mean 12 eggs. Or we could say a dozen horses, and know that that is 12 horses. So it's the same principle, in that it represents a specific number. So the mole is based off of the amount of molecules in exactly 12 grams of carbon-12 atoms. And it's represented as the number 6.022 times 10 to the 23. Similarly to how a dozen is 12, the mole is 6.022 times 10 to the 23. In this video, we're going to look at molar mass. So this allows us to see how to convert the grams of one substance to the exact grams of that same substance. So in this case, it would be H2O to H2O instead of H2O to CO2 or any other substance. So it has to be the same substance. And the molar mass is the amount of grams per each mole within a substance. Let's start off by looking at an example. So let's say we have 12 grams of H2O. And now we want to convert these 12 grams into the grams within 3 moles of H2O. So what we're going to do is start off with our 12 grams, then we're going to multiply by 3 moles of H2O, since that is what we now have. And then we're going to divide by the average atomic mass of H2O. So to figure this out, we have to go 2 times 1.008, and this number is the average atomic mass of hydrogen. And we're multiplying by 2 because we have 2 hydrogens in H2O. And then we're going to add whatever we get over here to 16. And the 16 represents the average atomic mass of oxygen. So that gives us 18.016 grams of H2O. Then we divide that over here. And lastly, we're going to multiply by 18.016 grams of H2O. And that will give us the grams of the new moles of H2O. So we went from 1 mole of H2O with 12 grams to 3 moles of H2O with exactly whatever we're going to get over here. So once we plug this into our calculator, we can see that we get 36 grams of H2O. And this number comes from, first off, canceling the grams of H2O here with the grams of H2O. Then we multiplied by the moles and subsequently divided by the moles. So all this is cancelled out. And that gives us the grams of 3 moles of H2O, represented by 36 over here. So this is how we use the molar mass to find out the grams of a specific amount of moles of any substance. However, we need to remember that this current process only works when we have from one substance to that same substance, instead of one substance to another. Additionally, we need to respect significant figures. So we start off with 2 significant figures over here, with the 1 and the 2, and we end off with 2 significant figures, with the 3 and the 6. And if you guys are unfamiliar with what significant figures are, otherwise known as sig figs, then I truly recommend that you go watch our previous videos on the topic to get a comprehensive understanding of what sig figs are, since they're very key in chemistry.